Hello guys, welcome to our next studies on linear functions. Today we are going to focus on graphical solutions to linear inequalities in one variable. Linear inequalities in one variable. We will be focusing on visualizing algebraic constraint on a number line and plane. What is a linear inequality? A linear inequality shows the relationship between expressions using inequality signs less than, less than or equal to, greater than, greater than or equal to. It involves variable raised to the power of 1. It means that the expression that we are talking about here is linear. It is of the form f of x equal to ax plus b. We've already studied that in our previous sections. Solution is a range of values, not just one value. So what we need to understand here is anytime we write an expression like x greater than 2, it means that we are talking about numbers greater than 2, not just one particular number. Yeah, when we write x less than 5, we are talking about numbers that are less than 5, not just one particular number. So, solution is a range of values, not just one value. The general forms of linear inequality can be in one variable, can be expressed as a greater than x greater than a, sorry. It means that here we are talking about only one variable, x, being greater than a. Good. Then we also have x less than or equal to b. So when we go to x greater than a, we are talking about values greater than a, all values that are greater than a. When you come to this side to here, we are talking about values less than or equal to b. It means from b and below, and this one is above a. Good. And when we come to the other part or other expression of the form ax plus b greater than or equal to c, this section 2 is talking about one variable, which is x. A, b, and c are constant. So to deal with this particular problem, we are also going to put in mind that we have to solve this one as an equation. Then what we need to understand here is we flipped the inequality whenever we are multiplying or dividing by a negative number. Good. So let's see the step for graphing inequalities. This is an activity for us. First one, we have to understand the inequality that we are working with. Number two, identify the boundary line. You can only identify the boundary line by turning the inequality sign to just an equal sign. So x is equal to k, where k becomes my boundary line, x equal to k becomes my boundary line. Meanwhile, x must be less than k or greater than k or less than or equal to k or greater than or equal to k. So I'll just get rid of the inequality sign, then represent the inequality sign with equal to. That will help me to identify my boundary line. After identifying the boundary line, I will draw the line in dashed form if we are dealing with less than or greater than, or in solid form if we are dealing with less than or equal to or greater than or equal to. These are the two main things that we need to put in mind when we are sketching linear inequality on a graph sheet. Number 4, after being able to draw our boundary line in the form of whether a dashed or a solid form, what we have to identify is the shaded of the region. So we shade right for greater than, and we shade left for less than. And number 5 here is after your shading, you have to label and verify to see if all the points at the part that you shaded satisfies the inequality. Well, let's go to an example. Take your time at this and understand this particular example. Graphing x greater than 3. Look at our inequality here. Our inequality here is x greater than 3. So at first, we need to identify our borderline. And as I said, to identify the bordered line, you will need to remove the inequality sign and replace it with equal to. So it means that x is equal to 3. So I'll go to my graph sheet, identify s equal to 3. So here, 0 to 2 is me 2 centimeters is 2 units. So in between, the middle become 3. Then that is where the 3 is supposed to be. Now, what am I going to do? I am going to draw a line at the point where s equal to 3, and it's going to be a vertical line which will be parallel to the y-axis. Why? Because there is no y value here. Good. So I'll draw the line. What line am I going to draw? Is it going to be dashed line or solid line? It's going to be dashed line. Why? Because it is the expression is of the form x greater than 3. It is not greater than or equal to. So I'll draw my dashed line. Then, since it is greater than, I am going to shade the right section of this particular graph. So this is a shaded graph. Then I'll verify to see if a point here will be able to give me value of x greater than 3. So when it comes here, this point is 0, 6. So x is 6, 0 rather. So x 6, 6. I'll put the 6 here. When you put the 6 here, you are going to realize that 6 is greater than 3, indicating this space of this shaded space explain or graphically identify the inequality s greater than 3. Good, let's try another example here. Y less than or equal to 4. When we are talking about y, it means that this time the shaded portion will be whether up or down. And it will be up when y is greater than, and it will be down when y is less than. So the same process used for x can also be applicable here. This time, the inequality here is less than or equal to. So we are not going to use dash line but solid line. So look at the solid line here. Good. Then we have been able to shade the down section here because we are talking about less than. Good. And you can text values and see. You can take this point here, s is 0 and y is 2. When you put 2 here, 2 will be less than or equal to 4, indicating that from we are talking about range of values from 4 and below. Good. Then let's see another graphing aspect, which is s greater than or equal to 0. The same scenario can be used. So look at this line. It is a solid line because we are talking about greater than or equal to 0. Then we are shading the right section because this is about greater than. Good. Then the same thing, y greater than or equal to 0. Here too, we are talking about a solid line because we are using greater than or equal to, which because this one is y. So the shaded part or the shaded portion will be facing the y-axis, which is up. Good. So let's move to the next one. Inequality with an expression for x greater than 3. As we said, when you get to this example, we solve for the value of x by removing the inequality sign and representing it with equal to. That will help us to locate our boundary line. So after doing that, we are going to realize that x equal to 3 over 4. Good. Then the shaded part will be, since s is greater than 3 on 4, it will be at the right side of 3 over 4. Note important things that we need to put in mind. So the dash line use the less than or the greater than, and the solid line use less than or equal to, greater than or equal to. Always takes a point to verify your shaded region if it is correct or not. Good. Let's see real life application and class practice. So for real life application, we can have speed limit. We can show this speed limit on the graph sheet. Age restriction, that is s greater than or equal to 18. We can also have income limit, s greater than 2,000. So there is a class practice for you. Graph x less than 2, y greater than -1, minus x plus 3 less than 0. Shade and label your graph clearly, and send your feedback to me personally or to this particular channel or to my WhatsApp number. Good. So let's see the summary of what we've studied so far. Linear inequalities give solution sets. Yes, it's about solution set because the results that we got from linear inequalities are in a range form. Good. The graph help visualize all solutions. So the shaded part of your graph will help you know that this particular solution satisfies the inequality that you are having. Then use line type and shading to show range. So the line type, whether it is dash or solid, indicate where your range is starting from. Thank you very much for listening and understanding this particular section. Keep learning with Roland High School Math Room. And in fact, your mathematics will be shaped into a new height. I'll be willing to receive all your comments and your feedback. See you on another time.